So adding and subtracting polynomials. So first you got to understand what some of the vocab that goes with adding and subtracting polynomials. So we've got terms. Expression with multiplication, with exponents, with radicals, with division. I think that pretty much covers it. Logarithms could be in there. Okay? It's anything that is being added or subtracted to something else. Okay? Addition and subtraction signs are what separate one term from another. Okay? So if I take all of these and I put like plus and minus signs, okay, that's what's separating them all as separate terms. Okay? Plus and minus signs separate terms. A couple other things. The number in the product the number in the product is called our coefficient. Okay? Whatever number is being multiplied by the rest of the term is our coefficient. And then we got a variable. You guys know what a variable is. Okay? So we got 8 and got -4 as the coefficient. All right? What makes a polynomial is a combination of terms. Okay? Where the terms don't have radicals, negative exponents, or variables in the denominator. And the negative exponent put variables. Okay? So a polynomial is an expression of terms in which all the variables have whole number exponents and there's no variables in denominators. Most of the equations that you guys are used to dealing with are polynomials. The crazy are not polynomials. Negative exponents, square roots, or variables in denominators, which again come from those negative exponents. So these are not polynomials. So we're going to focus on adding and subtracting polynomials. Whenever you are done adding or subtracting or simplifying a polynomial, you must write it in order of descending powers. Okay? The highest degree first, all the way down to the lowest degree, obviously skipping over any that aren't there. So fifth power, second power, first power, and then a constant is a 0 power for the variable. And then special names for polynomials: monomial, binomial, trinomial. Monomial means we have one term. One term. Binomial means we have 2 terms. Trinomial means we have 3 terms. And then anything above that, we don't have really a special name for. Okay? Because these special names for things that we use a lot. Alright? So once we get above 4 terms, it's just a 4th power or 4th term polynomial or 5-term polynomial. We don't have to need it. Most of the time we're dealing with binomials and trinomials and then occasionally monomials. And degree. Okay? Degree is the largest power of a polynomial. Whatever the largest power of the polynomial is. So if I have 2x cubed, the degree is going to be what? What's the power of that polynomial? 3. Okay, negative x to the 4. 4. 17x. 1. Okay? So each term has its own degree, whatever the exponent is. And then when I have a bunch of terms together for a polynomial, whichever one is the largest is the degree of the polynomial. So if I had all of these together, I have 2x cubed minus x to the 4th plus 17x. Which is the largest degree there? 4. So that's going to be the degree of 4. All right? So again, just varying degrees, squared, 14, linear, and 0, degree of 0. Constant has a degree of 0. If we have more than one variable in the term, you add the degrees together. Okay? So a squared b to the 5th is going to have a degree of 7. We add those together. And then again, with multiple terms, we're going to look for the largest. I've got 12, I've got 5, and I've got 2. So 12 is going to be the degree of the polynomial. All right? So combining like terms, which is basically what adding and subtracting polynomials is just combining like terms. All right? In order to be like exactly the same. So, if I look at A, what are my like terms? 2 to the 4th and z to the 4th. When I combine those, what do I get? 3z to the fourth. Okay, do I have any other like terms? 3x to the fourth, and negative 9x to the fourth. When I combine those, what do I get? Negative 6x to the fourth. Okay, do I have any like terms for b? I got 4r, negative 8r. I got 3t and negative 14. Okay, 3t and negative 14 gives me what? Negative t. 4r, negative 8r. Negative 4r. All right, this one's got a little bit trickier because you got to look really carefully. So let's take this one term at a time. 5x squared z. 8x squared z. Exponent and variable have to match exactly. Since the x is squared, I can only match the other set x are squared. 5 and 8 gives me my 13x squared z. Okay? Does this have a like term as well? Yep. With 12 to give me what? 9x cubed z squared. All right, and if we're going to write that in descending powers, we need to switch the order on that to get 9x cubed z squared plus 13x squared z, because the x has a larger power, so we need that largest power down to the lowest power. All right, adding is combining like terms. That's all it is. I take a polynomial, I add and combine like terms. So whenever you see these parentheses, all you have to do is make sure, do I have anything to distribute? If the answer is no, then you can just get rid of the parentheses. They're just saying, take this polynomial and add it to this polynomial. So we're taking our first polynomial and we're adding it to our second polynomial by just combining like terms. Negative 5p cubed plus 6p squared plus 8p cubed minus 12p squared. What are my like terms? Which gives me what? 3p cubed. 6p and negative 12p gives me close. Negative 6p squared. Okay. You can also add vertically. All right. You won't see it as often, but if you want to set it up more like a traditional addition problem when you first learn how to add and subtract, you can set it up vertically and just do your addition straight down. You have to make sure that your like terms are lined up. Okay. So negative 6r to the fifth and 8r to the fifth combines to give me what? Okay. If I have positive 2 and negative 2, what happens? Cancels out as 0. And then negative r squared plus 5 squared gives me 4r squared. All right. Combine your like terms. And all a whole bunch of the same stuff. Why are you not letting me skip over? That'd be great. Okay. Subtracting. Do I have anything to distribute with those parentheses? Actually, I do. So subtraction is going to be the same. We just have to make sure that we are subtracting all parts of this second polynomial. So we look at that as distributing the subtraction to the rest of the polynomial. We're going to distribute that negative here, here, and here. So then we end up having p to the fourth plus p to the third plus 5 minus 3p to the fourth minus 5p to the third minus 2. It's going to change all of those signs on the inside, and that is going to be a public mistake that anyone makes with these types of problems, is forgetting to subtract all of the terms in the second polynomial. A lot of times I see just the first one. All of the signs will get switched in the second polynomial, and then we combine our like terms. P to the fourth and negative 3p to the fourth. P to the third, negative 5p to the third. 5 and negative 2. 3. A whole lot of combining like terms. You can subtract vertically as well, okay? But remember that you're doing subtraction, okay? So you have to subtract each one. So there's a couple ways you can do it. One, you can try and just remember that you're subtracting, or you can do the same thing with that negative and change all of those signs. this may end up being more effective. So if I have 2k cubed minus 3k squared minus 2k plus 5, then I'm going to go ahead and I'm going to distribute that subtraction. I have negative 4k cubed minus 6k squared plus 5k minus 8. And that way I can just combine my terms straight down. I don't have to remember by adding my side. Look at what each one is. I have 2 and negative 4, which gives me what? Because I'm subtracting the second polynomial from the first one. So I distributed that negative just like we did up here so that I can just add straight down. Okay, because again, a lot of times what I see is that we forget that the second term and the third term and the fourth term have to continue to be. So if you rewrite it by distributing that negative, then we can just go straight down and not have to worry about remembering that extra step. K cubed, negative 9, k squared, positive 3, negative 2 plus 5, positive 3k, and then 5 minus 8, negative 3. Whole lot of combining like terms.